Chapter 6 Triangles. In this, we will learn basic proportionality theorem, that is also known as Thales theorem. As per the theorem, the definition is, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. That is, this is a triangle and a line is passing through, line D is passing through AB and AC, cutting the sides in two distinct points D and E. In that case, what has to be proved? The other two sides are divided in the same ratio. That is, these D and E will divide AB and AC in the same ratio. So to prove that, let us draw the triangle and the line parallel, DE parallel, and let us mark the angles formed. Okay, now proof. First, let us write what is given. It is given that in the triangle ABC, DE parallel BC, DE parallel BC, that is given. What we have to prove? AD by DB equal to AE by EC. That is, this D, point D and point E dividing the sides in the same ratio, that we have to prove. So to prove that, let us consider these two triangles ABC, the big triangle, and the small triangle ADE. These two triangles consider. So we can say that angle 1 is equal to angle 2. The reason is they are corresponding angles. Now this BC and DE are parallel, so this AB will act as a transversal. So angle 1 and angle 2 become corresponding angle and they are equal. Similarly, angle 3 and angle 4 also corresponding angle. This time this AC will act as transversal. Now what about angle 5? Angle 5 is common to the big triangle ABC as well as the small triangle ADE. So it is a common angle. So we got three angles are equal. So as per AAA congruence, we can say that these both triangles, that is triangle ABC and triangle ADE, are similar. They are similar. And we know that when two triangles are similar, their sides will be, the length of their sides will be in proportion. So we can say AB by AD is equal to AC by AE. That we can say. But we need to prove AD by DB equal to AE by EC. That we need to prove. So for that, what I'm going to do is, I am going to subtract 1 from both sides. Since the ratio is same, subtracting the same number 1 from both sides will not affect the ratio. So I am going to subtract. AB by AD minus 1 is equal to AC by AE minus 1. So as we do our fraction, here also we need to take the LCM. So LCM of the LHS will be AD. LCM of the RHS will be AE. So what will happen? It will become AB minus AD. Here when you multiply with AD, AB by AD into AD will get cancelled AB. Now here 1 into AD. So AB minus AD by AD equal to AC minus AE by AE. Now let's see, what is AB minus AD? AB is the long side AB. From that, if you subtract, what you will get, what will remain? This DB will remain. Similarly, if you subtract from AC, if you subtract AE, what will remain? EC will remain, is it? So we can replace AB minus AD is DB. So DB by AD is equal to EC by AE. So let us write up and down because both the ratio are same. So instead of putting dB by AD, I'm just writing AD on the top. If you write like this, it's no problem, but I'm just writing AD by dB. AD I'm writing on the top. Just I'm putting it reverse. So AD by dB is equal to AE by EC. That's our Thales theorem proved. Thank you.